Welcome to the overview of the Code Engine security features that will show you why this solution can be trusted even in the applications with elevated security and sensitivity demands. Of course, a successful integration of the Code Engine into a product will require forethought and proper application of some basic rules and constraints around this tool. Nevertheless, this is very easy to achieve with a minimal effort. You will see in just a bit. Let's talk about the risks. What types of risks exist when using a tool that allows execution of arbitrary logic within your product as if it were developed and deployed by your developers? An obvious answer is the unintended or unwanted dangerous consequences of running that logic. One is simply application errors. This is by far the least impactful, honestly, of three. Um, it's least impactful because it's immediately visible, detectable, ideally before it's even enforced, and can be addressed quickly by the development team or the users who are creating that custom logic. Another one is the information exposure, a far more serious risk. One may intentionally or unintentionally, although that would be hard to believe, may include some logic that potentially sends fragments of data to an external recipient, for example. Another risk is leaving data in a state of discrepancy or damage. In this case, the result may be truly unintentional and potentially disastrous. Each type of risk has at least one mitigation technique that can be applied to reduce or eliminate the chance of something going wrong as a result of executing the custom logic. Application errors caused by situations such as division by zero can be mitigated simply by testing. Creating specific unit or functional tests using compiled executors is one approach. Another approach will become available with the release of the Composer UI that will allow editing, debugging, testing models at runtime. Error handling around custom logic execution is a best practice and should be followed with 100% coverage within the hosting application. I hope this goes without saying. Information exposure is a more serious risk that is eliminated using two mitigation techniques. The first is peer reviews and segregation of duties between the users who compose the custom logic and those who activate the revisions of the subject actions. Namespace restrictions are another powerful and really bulletproof method for restricting or rather not relaxing the rules on what can be done within the subject actions. This is done by specifically defining those .NET namespaces or namespaces within your application that would be available within the subject actions so that one couldn't just easily initialize on an arbitrary object, something like HTTP client, and trigger a call outside the application. Finally, information damage risk can be reduced or mitigated by adding model validation within the hosting application after the custom logic execution, or simply using data annotations on subjects um, and enabling validate models after execution compiler configuration flag. This flag will make the executor validate the model resulting from execution of the custom logic and before it is returned to the hosting application. It may seem like there is quite a bit to do to adopt Code Engine, but there really isn't that much effort one should put into setting a safe and secure environment to empower users to be more independent in maintaining business aspects of the product that they use. Thank you for listening, and please submit any feedback on GitHub or YouTube. Thank you.